So to better understand the computation for the pre-stress loss due to anchorage seating, let us apply it in a sample problem. So a post-tension pre-stress beam has a span of 15.2 meters or 50 feet as shown. So this is the post-tension pre-stress beam. So it is actually a simply supported beam which supports a uniformly distributed load W and has a harp tendon profile. So the question asks for the anchorage seating loss if the estimated slip is 6.35 mm and assume that prior to transfer, the jacking force on the tendon was 0.75 FPU. So the other information given on the problem is the section properties at midspan, which has a dimension equal to this, and the location of the pre-stressing reinforcement is given with respect to the bottom of the concrete, and the FC prime, FCI prime, FPU, APS, and EPS are actually also given. Although actually we don't need all those given information for the computation of the anchorage seating loss. So without further ado, let's start for the computation. So recall that the formula for the pre-stress loss due to anchorage seating is equal to this, wherein the delta A is the magnitude of slip and the L is the length of the tendon. So actually, this is just a direct substitution. So if we will try to substitute the EPS, 186,200, and the given expected anchorage slippage, which is 6.35 mm, and the length of the tendon, which is approximately equal to the length of the beam itself for long span beams. So you can expect that for long span beams, the length of the tendon or the length of the tendon profile is just approximately equal to the span of the beam itself. So we can just use the span of the beam instead of the actual length of the tendon. So the span of the beam is 15.2 meters, but we have to express it in terms of mm since the numerator is in terms of mm. So by computing that, we can compute that the magnitude of the expected loss or pre-stress loss due to anchorage heating is just equal to 77.788 megapascal. So uh, you can expect that at transfer or prior to transfer, the pre-stressing reinforcement will experience a loss of pre-stress with a magnitude of 77.788 due to the slippage of the anchors. So you just have to take note that the percentage of loss due to anchorage slip becomes very high in short beam elements and thus becomes of major significance. So on this case, since we have a long span, actually the loss, the pre-stress loss due to anchorage is not actually that significant compared to the total loss that is being experienced by the pre-stressing reinforcement. But for the case of short span beams or short span elements, the magnitude of the anchorage slippage will be of significant importance or will have a major significance.